You're watching InTechnology, a video cast where you can get smarter about cybersecurity, sustainability, and technology.
Hi, I'm Camille Morhart, host of InTechnology podcast, and today we're going to have a conversation about water, specifically industrial use and restoration of water in semiconductor manufacturing. I've brought to the conversation Vanessa Lanas Delbridge, who is Senior Environmental Engineer and who is in charge of Intel's Global Water Stewardship implementation. Welcome to the podcast, Vanessa.
Hi, Camille. Thank you.
In general, can you just describe what water is used for in semiconductor manufacturing at sort of a high level? What are the different processes that use water?
Yeah, absolutely. So it's interesting because you wouldn't think of manufacturing site for semiconductors as using a lot of water. So you think that electronics and water don't mix, but we actually use a lot of water. Semiconductor is a very water intensive industry, and it's used at different levels. So first, in our operations, in our manufacturing sites, we take water and we clean it to the highest possible standards before it touches our wafers, which are the discs where all the implants and fun stuff happens just to make the chips that go into the computer and everyday equipment that people use. So that water rinses the wafer every time that something is done to it. Every time that you add a layer to it, layers of metals, polishers, and so on, it rinses the wafer and is used at so many of those processes. And then it's collected and it goes to a central location when it goes through certain treatment depending on what it has. So, for example, if it has some sort of metals or other constituents, it's pH adjusted and it is all collected and treated before it's discharged. Water is also used for our general operations. So, for example, cooling towers that regulate the temperature in our manufacturing sites and in our office buildings. It's used for abatement, which are the treatment systems for air discharges, and scrubbers, which also are another set of treatment systems for our emissions and effluents. And so water is used really throughout the entire campus, and our water footprint is pretty well monitored in our large manufacturing sites. We have digital twins of how our water moves in our campuses. Is pretty interesting, and that has allowed us to keep a really good hold of how we are managing our water resources.
Oh, can you just elaborate on the digital twin for a moment? What is that, and what does it look like pertaining to water?
Yeah, so we started developing water models for our large manufacturing sites in the US, in Israel, and in Ireland. They all have these water models that essentially show you in a big screen. It's a software that shows you how the water moves, how much water comes on campus, where it goes, how it's treated, how it's collected, where it's saved or stored, and how it's discharged. And with that, we're able to have a really good idea of how we're using the resource. And that really has helped us to manage the resource more efficiently, because we know where there's some room for optimization or how we could segregate certain waste so we have better quality wastewater discharges being sent and being reused in other parts of campus. So we have gotten really, really creative with that, and we have a history of almost 3 decades of efforts and investment in water conservation efforts. So these digital twins, these water models are a really good, they give us a really good sense of how we are using the water that we also share with other stakeholders in our watershed.
Where does the water come from, essentially? Is it from, groundwater? Is it from rivers, lakes, oceans?
It's pretty interesting, and it's pretty mixed. For the most part, the water that we use is water that we purchase from utility providers. So every city offers water depending on where it's available for that specific location. So I would say that mostly water comes from rivers, and then it's treated and offered to Intel, just that it's offered to any domestic users, like in neighborhoods and other businesses in the areas where we operate. In some locations, for example, in Israel, we are using seawater that goes through desalination process and then it is used for our manufacturing processes. In some cases, I know that there's a mix of groundwater plus surface water. And even in some locations like Arizona, we purchase water that has been reclaimed by the city. And we really hope that that's an option that becomes available more and more, because we would really love to use water that is not taken directly from the watershed, but water that has gone certain treatment and can be reused by Intel.
Okay, so give us a sense of how much water is being used, but sort of globally, what is the quantity of water we're talking about here?
Yeah, so last year we used over 11 billion gallons of water globally. So that is a sizable amount of water.
Okay. And in the annual report where you publish kind of different projects that rise, that sort of sustainability goals and track progress toward them, it says that Intel has a goal of restoring 110% of the water it uses. So how do you get to over 100%?
Yeah, that's a great question. So that the goal is to be net positive water, which means that we are going to return to the environment more water than what we use in our operations. And you're totally right. We don't make water. So how is it that we are getting to over 100%? And so that has two main components. So one is the waste, the water that we use in our day-to-day operations, and we treat it and then we discharge it to the city for where it can be further treated and can go back to the river or can be used for different purposes. So that is water that is returned through wastewater treatment and discharge. That accounts for around 80% of the water that we use on site. So the delta, the difference, the 20% difference is water that is generally evaporated. And there's some other small losses, like, for example, irrigation, or is water that has gone through some leaks, or is it water that has been shipped off site as part of our wastewater trucking. So I'm sorry, our waste trucking off site. So that 20% is what we want to, compensate with external water restoration projects. And we partner with several nonprofits where we operate. Some are large global nonprofits and NGOs. Some are more regional, and some are pretty local. And they're really the experts of the watersheds where our campuses are. We operate on a watershed basis because we that we understand that we are really impacting the watershed, and we really want to contribute to its health and sustainability. So we fund these water restoration projects that return certain volumes of water to the environment. And we work with water experts who help us assess and evaluate these projects. There's a methodology that is used to just really quantify how much water is being put back into the environment through these water restoration projects. And at the end of the year, we account for those volumes. We have them validated by this third party, our third party consultants, and that helps us with those returns to the environment. And that is what has helped us worldwide to achieve 110% of water returned in 2023. Now, I have to say, this 110% does not necessarily mean that we have achieved our goal of net positive water. We achieved it for 4 countries. So for the US, for India, for Costa Rica, and for Mexico. But we will consider that goal achieved, and that's a goal that we set by 2030. We will consider that achieved when every one of our locations has achieved net positive water.
So I understand that each of these watersheds, especially if you're comparing like Arizona and Oregon, for example, in the United States, one very wet climate, one very dry climate, that you use very localized programs, like you're saying, through NGOs and other groups. Are you funding the treatment of water that's coming out of, third-party manufacturing facilities to gain that water back, or how does that happen?
Yeah, so it's we have a portfolio of 45 projects that we have funded so far, and all of them are very, very different. And it really depends on what the needs are for that specific location and watershed. You're right, the needs of our sites or of the watersheds in Oregon are going to be very different than the ones in Arizona. So we really rely on the experts who help us assess what the needs are and what the opportunities are in that specific watershed to select the best projects that can be really impactful for our communities and for the environment. Some of those projects are nature based. So the simplest example is tree planting. So for example, we've contributed to, through to projects that have planted trees in locations that lost all their vegetation because of wildfires. Or, for example, our nonprofit partners have developed projects that improve the irrigation of certain crops, or crop replacement where you have some crops that use a lot of water and that has been replaced by crops that use a lot less water, and they are more native and they are much more resilient to drought. That's for the nature piece. We have also funded some projects that are more urban based. So, for example, in Malaysia, we funded projects that help conserve water in schools by replacing some of the equipment that they have. For example, when the children are going to wash their hands, so instead of just letting it run, it's just a top faucet, and then they just use the quantity that they need, and that brings some significant water savings, and that is what's accounted at the end of the year. So the portfolio of projects is pretty diverse, and it changes based on the location.
Can you talk to us a little bit more about what Intel's doing for water conservation?
Certainly. We have different actions and projects in the space of water conservation in our operations. One of the main ones are our 3 large water reclaim facilities that we have in Oregon, in Arizona, and in Israel. And these are large, state-of-the-art, on-site treatment facilities that treat our commingled wastewater, and that allows us to use it back into our operations. So it goes to cooling towers, scrubbers, and other facilities. So those are really large investments that Intel has made that save billions of gallons of water per year.
Oh, that was a question I had. Okay, so I was reading in the annual report that there's a lot of savings now, but that it's almost an order of magnitude more, that there's processes put in place where there's going to be able to save 200 million gallons of water or something along those lines. Is that what you're talking about right now, the reclamation facilities?
The reclamation facilities are there, and they are operating in full capacity, and they bring back billions of gallons of water per year. But the global water management team at Intel continuously explore new opportunities for water conservation. So maybe what you saw in the report is other projects that we have in line and are at different stages of development, right? So we have projects that are in the concept phase, and other projects that are being in the design phase or pilot or full implementation. And those are projects that are going to save Intel potentially millions of gallons of water every year, depending on the size, on the scale, and where they are implemented. And those are really interesting projects that have a good ROI. So projects that really pay for themselves eventually down the road. And they save a lot of water in terms of the fresh water that we take from the watersheds. So we are able to reduce that amount of water because of these water conservation efforts.
What can you tell us about one of those innovative approaches? Like, even if it's early in definition, what's an example of something that kind of takes it to just another level?
Yeah, so we have really interesting projects at the tool levels. So to manufacture to develop these wafers, there are certain tools that are being used, right? And each one is very specialized and need water in certain capacities, and we call them recipes. So, and that's when the water does certain flushes or cleans the wafer in a certain way, and when it's in idle mode too. So when the machine is actually not operating or just waiting for the next batch of wafers to just go through it. We have been able to work with the tool designers and builders and ask them to optimize these tools to use less water. So that is something that's pretty innovative because that tackles directly into our supply chain engagement when we are really working with those who supply us with the tools for the operations and optimize the water use. Another example is at the same tool level, we are being able to reclaim some of that water and recycle it to the front of the tool by just doing smaller adjustments to the tool, adding some cabinets, treating it like right there when the wastewater is being generated, it is treated and it's just going back to the front of the tool. And with a couple of those pilots, a couple of those successful stories, that is being just cross-pollinated to all the high volume manufacturing sites.
Vanessa, how did you get interested in water conservation and sustainability?
Yeah, it's been an interesting journey. I think water has been present in my career since pretty early on. I loved studying water and being involved in water in all its shapes and forms. So I've done domestic wastewater, industrial wastewater now, groundwater treatment. I've done stormwater management, research on potential wastewater treatments. And now I'm really glad to be in the field of sustainability and being able to kind of like go back to the ecosystem piece of that and the watershed piece of that. It's been kind of the compass in my career, being in water. And sometimes you stumble into some things and then you just stay there because that you have a passion for it.
Are you originally from Ecuador?
I am, yes, from Quito, the capital.
Okay. And that's an interesting place because it's up in the mountains, but then the Amazon basin is all around it. I was just wondering if that may have influenced your interest in water.
Yeah, maybe it was. So no, when I was growing up, water, I think this is true for a lot of people, you don't think too much about water. Water is this resource that you just have available, and you just open your faucet and there it is, clean, available whenever you want it. And Quito, being in the Andes, has really high quality water because it comes from the highlands and it's collected and it's brought to the city, and it's really great. I always say that no water tastes like the water from back home. Yeah, I don't know where this interest in water came from. I always knew that I wanted to dedicate my professional life to the environment. I always knew that I wanted to do that. I didn't know if I was going to be an ecologist or a biologist or something, but environmental engineering is something that just really popped up and it really became my passion. And I'm so glad that I chose what I chose. And through different professional opportunities at the time, I started exploring water more and more, and then when I did my master's, that became my main center of study and research. So I think that's where I really started focusing on water.
Vanessa Lanas Delbridge, a senior environmental engineer with Intel, responsible for global water stewardship for the company. Thank you so much for your time today. Thank
you so much, Camille, for having me.
And we'll put the link in the show notes below to the actual annual report that Intel produces. There's a section specifically on water use and restoration within that, as well as a whole bunch of other information about sustainability. Thanks again.
Thank you.
Never miss an episode of InTechnology by following us here on YouTube or wherever you get your audio podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.